we are going to learn about exponential equations.
I feel like I'm not going to like that.
I think you are going to like that. So an exponential equation is when you're solving for x in the exponent. Like they have 3 to the x equals 81. What's x?
4.
X is 4. Nice. Now how did you do that? Well, you knew from your powers chart that 81 was 3 to the 4. And if these are the same, it's pretty obvious that those have to be the same. Does that make sense as a strategy? If the bases are the same, then the exponents would have to be the same. Like if I said 2 to the x equals 2 to the 231. What's x?
What is 2 to the 231?
A very big number, big enough that your calculator would probably go. Try it. Maybe it works. Maybe it's too big for your calculator. Then, yeah, it's just that easy. X would be 231. So this will be the first main strategy.
Why did you write the 2's different?
I have, the bases are different. I have been trying very hard over the last 2 years to train myself to make 2's like this.
I like my 2's
Okay?
without the
Because when I made 2's like this, I didn't know if it was like, if they're too close. That 2 is too close to the z. And then that, so I'm trying to make my 2's like this. So it's a work in progress. I think I'm at about, the last statistical check, about 82% of the time, my 2's come out like this. The other 18% of the time, they still.
But it's only 30, like, it's 25% right now.
Yeah, this is a really bad, you got me at a bad time. Grammatically and mathematically, I'm struggling. And lately, I've been quite disappointed with my 5's. Yeah, they're like, oh, I hate that.
No, that's me. I do that.
So I'm really trying to get that bottom part right there to be pointy, but it's not happening because I like that 5, right? And I'm like, ooh, yeah, I have been. I've been doing this all in one motion, but I don't like it. So, I've been having issues with that. Same thing. My 8's in the last 10 years have switched between this and this,
I like the
right?
I do this both ways.
The 2 circles take way too long.
Yeah, it's too long, so I have to go back to that. Anyways, we are on question 1. Enough video analysis of numbers.
Where is that question? Oh, yeah.
right to the side.
So the main idea that we're going towards is if we can write, using our exponent laws, both sides as the same base, then we'll be able to solve for the exponent. Sometimes it's really easy. Sometimes we have to use some more exponent laws than we're used to. So the thing that we're going to look at, as in A, the numbers on both sides. One of the side is a 4, one side is a 256. In your powers chart, is there a column? In other words, is there a base that both have 4 and 256? 4. How can I rewrite 256? It's 4 to the power of 4. But at this point, on the one side, I have 4 to the x. On the other side, the 4 is in my denominator. Do I have an exponent law that lets me change that so I can write this side as 4 to an exponent of something as well? -4. And once both sides are powers of 4, you can just say, hey, I know what x is. X is equal to -4. Now, at this point in math, we're using logic. it makes logical sort of mathematical common sense that if 4 to the x equals 4 to the negative 4, then x has to be negative 4.
When you flip like a fraction, does the sign of the exponent always change? It's never the base.
Yeah, the base stays the same. It's just the exponent becomes negative when you move it from denominator to numerator, or you can do vice versa. You can move something from the numerator down to the denominator. So there's A. Now, A was easy because the 256 was in the column of 4. You could have also changed this to 2 squared and this to 2 to the 8, but this is easier. However, in part B, right, do you ever have a 27 and a 9 in the same column of your powers chart? What power? Power of 3. So you have to change both of them. How can I write 27? I can change 27 to 3 cubed. I would still have to the power of x outside. How can I change 9? It's 3 squared. And I still have 2x minus 1. Note the perfection of those 2's. Now, what exponent law can you do here? What is the power? How do I do this? 3 to the x. What would I write? Is this adding? This is multiply.
Just kidding.
Just kidding.
Because you're having tricked, huh?
Yeah. Every day.
It's a little awkward.
That'll be good. And unlike the last one, where we could just say, oh, x is minus 4, this one we can't say right away what x is, but if the bases are the same, would you agree that what's in the green boxes has to be the same? So I often like to go, so, 3x has to equal 4x minus 2. Oh, I can't do it. Okay, work on it. Here we go.
Now I picked my 2 just because you
Yeah. A little bit of like terms. X is equal to 2.
Oh, I remember doing that.
Questions for practice are